All right. Now, this is the point that we stopped there in the afternoon. So we will continue. So what is the thing here about this program, previous program, is about the reentrance property, whether you can let it handle for you the signal using the handler here. And now the handler is, kind of you switch to another world. There's students ask me, hey, what exactly the meaning of a handler? Is if we have two different worlds, okay, although it's in the same program, the two different worlds, one is your code, which is executing starting from the main, and another world is the handler. So as if you have two pointers pointing to the instruction, you start the execution, yes, say from the main, and then go to sleep, and then you point to sleep. That sleep is kind of executing because it's doing countdowns until the 24 hours later you won't wake up. Now, another world means that there is another functions belongs to your program. When you receive a signal, you kind of ignore what you are doing, like at the sleep, and then you switch to the handler and continue to execute the handler's body and go back to the original code. Now it's based on the definition of the system call. Okay, so the system call say that, well, there's two guys. When it's implemented the sleep and the pause, you cannot reentrance. Stop there. Another guy, a set of guys, okay, the open. Yeah, you will find a little bit strange. Why open have a chance that you will get stuck there? Okay, I don't know you have the experience. I expect that you don't have the experience. Is floppy. Okay, you open a file in a floppy, so it will take times, and during the time you may have a chance that there are signals coming in, and you handle it. Okay, so the open system call guarantee that when you open this thing that takes time, you won't get interrupted, or I would say you get interrupted, but it will still restart and continue until the end. Okay, so read the write also. Imagine that the write call is the right things on the floppy or network, so on and so forth. Those are slow media. Okay, the wait system call I explained to you that it was still waiting until there is a real termination. Okay. Yeah, just take a seat. I cannot move. Okay, I'm this. Let me check again. How come this? It seems to be. Oh, yeah. How come this doesn't work? All right. Now this is something extra because I don't expect you to remember it, and this is also something extra because we seldom use signal in that way. So what is this program? I give it 1 minute. Now whenever I give it 1 minute, look at the code. Remember, look at the system call. Can you find fog? Yes, you find fog. All right. And identify which part is the parent, which part is the child. There is an extra system call that I never told you before. This call is called get PPID. So what is this guy? Get parent PID. Okay, so to get the parent's PID, yeah, it is possible, but you cannot get a child's PID. Okay, so you only have one parent, so it's get PPID, and the signal that you will fire per, I don't know how long. Okay, you read the code and tell me. Okay, and fire 10 signals using the Q system call. I give it 1 minute. You take a look. Tell me which part is the child, which part is the parent, what the parent will do, or whether the child will die or not, who die first. All right? So, go ahead. And in the meantime, I fix the mic here. Yeah, remember, fog is there. Look at where is the parent, where is the child. Hey, what? Oh, yeah. Wait. Okay, I damaged it. So, which part is parent? The if case or the else case? Yeah, if today you cannot distinguish this, that means that you don't know how to do assignment 1. Okay, and tonight is the assignment 1 deadline. Tonight, remember it's tonight. Don't say, it's tonight? Okay. Yeah, it is tonight. So, which part? Else part is parent or if part is parent? Else. Okay, the else is parent. So that means that this wait call is it's okay, right? I put it in the correct code. Okay. So the child, will the child die immediately? No. You find that there is a get child. Okay. I love to write this in this statement, right? So a get child there, so you will be get blocked there. So this is actually is a ready, right? As in show in this area, I'm ready. And when you go to fire the signal, you will press enter. When you press enter, go to the loop, fire for 10 times. Okay, fire for 10 times. Now, why I put a sleep here? Because I want you to also illustrate that, hey, you are handling something. You have a handler. And this sleep will also be broken. Okay? And then the wait depends on who died first. Okay? Oh no, I shouldn't say who died first. When it reaches the wait, whether the child is die or not. Okay? Now let's run the code and see what happened. So let me go to the correct place. Wow. Should I shut it down? Okay. So the main signal, so it's get ready. When I fire, let me take a look. What is the number of signal? Maybe I change it to 1 million. What already shut it down? Why? Oh, it don't allow me. Okay. So 10. All right. So ready, fire. What does that mean? Take a look. So this is the result. The count only say 1. And why you get 1? Now take a look here. I create a static variable. I hope that everyone knows what static variable, right? Yeah, static means that you're always there. Whenever you initialize it, when you update it and revisit it, it will keep its old status, right? So that means that the 1 is got updated once and then you print it. Now, after this firing, okay, this batch of firing, the child dies, okay, and when the child dies, termination of the parent will be also, it will die, right? Now, this means that I can only handle once. Does it true? Is it true or not? Let's try something. 1,000. Okay. Compile again. No problem. Run. Ready? Go. 22. Try one more. Yeah, 100,000. Okay, I fire 100,000 times. Compile. Ready? Fire. 800. Or maybe next time it's not 800. Ready? Fire. Now this time it's 1,090. I don't know why actually. Don't ask me, hey, why there is 800 or 1,000. I don't know why it gives you this number. But I know why it's not 1. Or why not 100,000 or 10,000. Okay? So what is the secret behind it? The secret behind it is very interesting. Now, first of all, I have an illustration here. So this is the code. The illustration, we can explain to you that what exactly behind the screen is signal handling is a Bitmask, a mask, okay? A bit arrays. We call it usually a bit array, we call it Bitmask, okay? So bit arrays originally is 0, it means that that signal doesn't get sent to that process, which is initial configuration. If you get a signal arrive at that process in a kernel, that 0 will become 1. So only on and off. Originally, nothing. Now you get some signal, I don't know how many, I turn it to 1. Okay, so either turn it off or turn on. Now, what is the problem here? The problem is when you firing a whole bunch of things, okay, it takes some time, right? Let's say 10 milliseconds, okay? Within 10 milliseconds, you will trigger. Now, take a look back into this code. This code involves two processes. Process A keep firing secure non-stop, okay? It takes 10 milliseconds fire to that process, and that process know that, okay, I got some signal. I try to handle it, okay? And the handling is short, very short here. Okay, this is the handling. Now, during the handling, kernel basically ignore the later coming signal, or out. You can imagine it whether it's pause or ignore it, doesn't matter, right? The point is, while process A is firing, it just accumulate a set of things and handle it once, and when it finish the handling, it will find that, hey, why process A is still firing at me? Okay, I handle one more time. But in that interval, how many get accumulated, we don't know. Okay, but this is the effect. Okay, so I can try something interesting. How about I keep firing it, but I do something stupid within the handler. And why I want to do something stupid, I want to slow down the handling. To slow down the handling, I do this extremely stupid thing. Yeah, very stupid call. Just loop for some time. In order to slow down the handler cannot be so fast in order to handle another time. Okay? Then, even though I still fire so many signals, you will see the number of counts decrease. Previously is sometimes got this 1,900. Previous trial it is maybe I try one more time. Now this is 1,000 something. Now I compile the code. Now make sure that you understand that this is being slowed down. A slow handler. Fire it. Go. Change a little bit, right? Keep on increasing it. Yeah, it's crazy, right? But let's go. Even more slow handler. Fire. Eh? Oh, come on, baby. Okay, this time, okay? It's being record, okay. Try again. Oh! You are the naughty guy. Sleep one. No, sleep one is too long. What are the, I remember, it's called, not X-Men, okay. Nano sleep, you sleep, right? Let me call it, it's called you sleep. We can sleep for some time. Let's try that. Hey, what is the code? Oh, the code is here. So you sleep. Let's try sleep for some time, not smaller than 1 second. Don't cheat me, Go. Much better. That for loop is not trustworthy, okay? Yeah, we should use sleep. Yeah, much better result, and it's so happen that my explanation fits, okay? So this is one of the thing that don't try to count how many incoming signal. It's nonsense, okay? And then you can try go home and or even now try one of the following, okay? So what is the first one? Segmentation fault. Second one, do you know what it is? Can you guess what it is? F stands for floating point exception. Yeah, floating point exception. What is floating point exception? Never heard of it. Okay, so you guys already write correct program. You are powerful, huh? How come you always write correct program, huh? Okay. Let's not say. Wow, it's so loud here. Floating point exception. Return 1 divided by 0. Okay. You never see this, right? So that's why I don't need to include. Okay. Then compile it. Yeah, already see something about division by 0. I don't care. Let's go. It's just warning. Huh? 有似你啊！ Okay, I surrender. Print F, okay. Return 0. Oh, yeah, one more. This must work, huh? If it don't work, I don't teach. You? What's that? I don't teach this part, okay? What's that? Yeah, take a photo, huh? What's that? Yeah, I don't know how, okay? I don't know how does it happen. ENGG 110 is okay. Why this course is fail, huh? Next time I show you another example, huh? Okay, so let's try this, okay? So this must be working, okay? The segmentation faults. You already tried it, right? I tried to dereference a null pointer, okay? Now, even inside the handler of the segmentation fault scenario, the handler, I can do other things, okay? So the end result will be very funny. What? What happened today? Save. Compile. Run. What? Today is a bad day, huh? Minus 0. Oh, okay. Go. It's too horrible. So you see, it works, okay, and pretend to be press anything to continue, okay. It's interesting, right? And actually, there's a code there with segmentation faults. All right. So go home and try it. Wow, very horrible day. Yeah, you know, when night fall, everything can happen. All right. So we try something more. These are some. I know my bad. Okay. Yeah. Don't complain. Don't complain. Yeah. Although this complaint is interesting. All right. There are some special way to use signal. There are different people using different ways, okay? I have several recommendations to you. First of all, one of the recommendations I don't recommend you, okay? I love to handle Control C. Later on, I tell you why I do this. The first one is the port system call. Well, it is very good, right? Previous case, I always use the get char, right? To get char to pause the program. And in order to pause the program, I have to send a enter. Okay. Now this is what we call waiting for I/O event, right? You're waiting for I/O, and you press enter to get out of jail. Now I set up another type of jail, which is based on signal. What is that? The port system call is interesting. By definition, in the main page, it says a signal which is handled by a process will trigger it return. So what is the meaning? The meaning is this program, right? Look at this program. I have an empty handler. The handler is completely empty, nothing, okay? And I handle, this is a sig in, this is a Control C. I handle Control C, and then I invoke pause. Then the process is not waiting for I/O. it is completely shut down, okay, or suspended. It's put in the, not the background, but away from the CPU, okay? And waiting for what? Waiting you to interrupt it using Control C, okay? When it's got Control C, it will return as if just like sleep, okay? Then we'll continue. That's right. Today's horrible. Let me change the makefile. This is because of the makefile. Ayah! How come it should be 0? That's why. Very horrible. Alright. Compile again. Compile them, clean them. Okay. Much better. No, pause. Alright, so it's waiting for me to press Ctrl C. Now, believe me, it is away from the CPU now. When I press Ctrl C, it will say, oh, I add something more to the program. So what is the program now? I add something. I detect whether it is a sig-in. If it is sig-in, then I will say that, oh, sig-in is received. Okay, and last, I will say is terminated normally. Or it's not. If not, it's not normally like I terminated using Control /. Okay, then it will say quit. Which is a sig quit. The sig quit, I didn't handle it, so it will be killed without interrupting the pause system call. Yeah. All right. And the pause system call is behave another way. Just like previous case, if it is being terminated, it will return, but it's just nonsense, right? It's already terminated. So pause system call, I usually use it when try to put a stop in a program and wait for the interruption from the user. Another type of usage of signal is breaking out of a loop peacefully. Okay, I know what you are thinking. So what is the meaning of peacefully? Yeah, look at the code here. The code is using a global variable to control whether you should continue to loop. Okay, so as if it is an infinite loop, it will start with 0, the stop variable, and while it is stopped, it will keep looping, the infinite loop. Now, when I press Ctrl C, I change the value of global variable so that it won't loop again and die peacefully. So this is another way, okay, which is good in terms of some complex program. What a complex program? How many of you are taking database? Yeah. So I don't know which professor, but does he or she tell you about there is a thing called transaction, rollback, commit? No, not reach there. Yes, it's still select from where. Yes. Okay.
Yes.
Good. Okay. So let's say you're updating a row in a database in a loop. Okay. Updating, but you didn't say that. Oh, close the connection. To close the connection, you understand. Updated and close the connection means that I write the things in the database. But you didn't do it. Okay. So usually I will use this trick. Okay. I want to Control C, kill the program, but I know that there is something really important going on. Okay. One of the trick is to set up this kind of a peaceful loop. Okay, there's not infinite loop, but when you press Ctrl C, I know that okay, you want to stop. Let me finish the things remaining inside the loop, and when I reach the bottom of the loop, I will leave. Okay, so this is one way. Another way is something that I skip here using the sig action call. This afternoon I tell you about that. The signal is the old standard. New standard is a sig action. The sig action family, there is a call to shield signal. You shield a signal for some while, and then you remove that shield, immediately you receive it and die. Okay? So this is one way. And the last thing is about timer. So what is a timer? So timer is very interesting thing. It's related to hardware. So the alarms is a system call. Is related to hardware. When you say that I want to set up an alarm 5 seconds later, you will write down alarm 5. Now this means alarm 1 means I set up alarm 1 second later. Okay? And what is alarm? Let's try it. Alarm.c. So I try 3 seconds, and during that time, okay, that 3 seconds before the alarm, I will just like crazy say hey, okay, hey, 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 and until when? Oh, sorry, I hide it, okay. Again. Oh, you say hey, 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 and I'll stop. And suddenly it said alarm clock. Okay, so what is that? What is that? Don't worry, yeah. Let's take a look. Signal. Oh, man 7 signal. Take a look at the signal main page and go to SIG alarm. Where are you? Oh, here. SIG alarm is here. So what is the TERM here? Termination. So that is the default action. Whenever you set up alarm, it's just like the countdown clock of that process. After 5 seconds or 3 seconds or 1 second, it's up to you, it will die. Okay, and will be killed. So this is the alarm. And alarm here, basically we'll go through this. You set up an alarm, so you go to the system because it's hardware. If you're a CE student, you will heard of there's a Motorola clock chips in every motherboard. So that alarm, I mean really that alarm, is set the alarm on that hardware level and trigger that hardware clock to fire something to the CPU so that it will kill the process. Okay, and then the SIG alarm comes in from the hardware and try to kill your process. Of course, after that it will become zombie. And because I have a shell, so a shell will take care of it and remove that zombie. All right. So this is a simple alarm. And well, if you want to know more, you can play this. This film-like animation by yourself. This animation is just give you a clear picture, but I already said about this. Now I give you something harder to understand. Actually, the alarm system call is very, very useful. Okay, sometimes I will use it, but not always. So what is this program is about? This program don't have fork, so you don't need to find where is a child, where is a parent. It's just executing something from the first line until it's reached the end. Okay, and we have two alarm clock system call. One is a setup of the alarm. 5 seconds later, you will get killed. Another, alarm 0. It doesn't mean that after 0 seconds you will be killed. It doesn't mean that I will kill you immediately. Okay, 6. It means remove the previous alarm. Okay, alarm 0 means remove. Okay, so what this call combine mean? The combination here means that I have a handler here, and the handler is about a SIG alarm. So if that alarm clock signal fire, I will kill myself. I just want to print something, so I handle it. Okay, let's try it. Alarm F with F get S. Okay, so let's say I remove the exit. Okay, maybe I put it back. Okay, and still it is defined by 5. Okay, and then I want to read something. If I successfully get something, I will remove the alarm and then print things. All right. Oh, I already make it. So let's press enter and wait for 5 seconds. 5, 4, 3, 2. Oh, I'm bad. I sucks. Okay. Yeah, take a look here. So if I didn't remove the comment previously because I removed it, but I didn't compile it. Okay. So it will say timeout goodbye. Of course, if I compile it, why I say I compiled it, I remove the exit here. Compile it. Run it again. You count 5. I don't count this time. I suck. So. Wait. Okay. Then it will kill itself. If within that 5 seconds, I type something, hello, enter, then it won't kill you. So what is the purpose of it? It can be a countdown clock for you enter a password. right? You implement something, you ask someone to input something and tell you that you have five seconds to complete your input, and it was still counting, and if that guy fails to input the things within 5 seconds, you say that, hey, timeout, quit. Okay, so this is one of the mechanisms. All right. So I can only think of the 3 interesting ways to use it. Okay. Some people will also think of, hey, how about periodic signal? Can I set up periodic signal? Yes, as long as you handle that alarm, handle the SIG alarm, because SIG alarm will kill you. Okay. So how come you have a periodic signal? So you have to handle it so that it won't kill you. Then how to set up periodic signal? Any guess? I don't have code here. How to set up periodic signal? Let's say my periodic signal is to tell the user that, hey, 5 seconds has gone, please enter. And another 5 seconds, just very annoying, keep on saying, oh, 5 seconds is gone, please enter something, 5 seconds is gone, please enter something, very annoying, okay? How? Just one line of code. Huh? Yes, exactly. So let's try it. So he said, remove exit, okay? Calling alarm in a signal handler, okay? So I know a 5 is too long, maybe 2, okay? Wait for 2 seconds. And because you already handle, oh, of course this time is not goodbye. This time is go on. All right, come out, run, wait 2 seconds, and then 2 more seconds, 2 more seconds. While I'm typing hello world, I suck, so I type very slow. Okay, enter. Then I still get the whole string. Okay, no problem. So this is the way to periodically send something to remind your user. Okay, some people don't like it. Okay, some people will use another call, which I don't teach here. You can take a look at the menu page. It's called set interval timer. Okay, so you can set an interval timer to your process, and you receive it periodically. Okay, so of course this is the end of the lecture part of the signal. Okay, so there are something that I didn't cover. Let's go back for a page. Okay, the use of these 2 guys. The default handler, you can put down default handler here, the function name, or the ignore. Okay, our tutor should have tell you about this. One is ignore, one is default. Okay, if you set something handling to whatever function, but you want to handle it once only, okay, you can use SIG default to change it back to default status. Let's say the default is Control C termination. You want to handle it once only, then you can use the default inside your handler to set it back to default. Okay, and also for the ignore will totally do nothing. Okay, and some other things that you can look it up. And one thing about signal is about the, let me open up something that you don't want to see. Yeah. Oh, by the way, oh, it's not something you don't want to see, right? Because when you come here, it means that you already submitted, right? No? Still doing? Oh my God. Yeah. I think that you come here because you have finished it, okay? And yeah, we have something described here, so-called the incomplete job control. And I explain some of the defects. Okay? So what are the defects? Defects basically is the description is like this. Okay, you have a cat. Okay, and the cat is sleeping, and you want to kill the cat, kill another. I mean, but the other cat is here is running at the foreground. One is in the background sleeping. So what this Control C means? It means you're killing the foreground, right? But unfortunately, when you try to wake up the background cat, that cat is dead as well. Okay? So the meaning now I can tell you is about signal, of course. Control C is sig in termination, right? You will terminate the foreground cap. But the terminal treat this to a wider level. So what is a wider level? The terminal, not the shell is written by you, right? The terminal who receive your keyboard input, treat this as we call broadcast signal. Broadcast. So what is the meaning of broadcast? Broadcast to all processes being created by your shell. Okay? It's actually being a bundle together. Okay? And when you send a control C there, actually your shell will receive it. The sleeping cat will receive it. The foreground cat will also receive it. It's called broadcast signal. Okay? And that's why this guy died at the screen. Yeah, poor cat. This guy sleeping but already get killed. And if you try to wake him up, you will find his dead body. And it's gone. Okay, so it's a broadcast signal. I already find some student, at least one, okay, asking me how to do it. How to do it the better way. Okay, I already given some hints in this kind of keyword. Go ahead and take a look on this kind of man pages. You'll get an idea how to set up what we call background process group. Okay, so this all we call it foreground process group and get fire to the foreground processes. And this is also the explanation why Control C can kill fogball. Okay, why? You are creating a lot of processes. They are running at the foreground. I press Control C, basically send the broadcast signal to all fogball. You kill them all. Okay, so that's why in the previous demonstration, I can get away from the fogball attack by just one Control C. Okay, so this is why. And of course, signal is a very big topic. Okay, this is true. Whenever I teach this topic, I'm not very bad at this topic, but this topic is too broad. I usually have to look at man page, and you can see in the spot here, I fail my demonstration, so on and so forth. It's because it's kind of evil and also many system dependent things here. Okay, so this is about signal. Any question you want to ask? Anything you want me to try? Yeah, except we put my computer.
When did you suspend your computer?
Which one?
After setting up an alarm, for example, 5 seconds later, what if you immediately suspend your computer for more than 5 seconds?
Very good questions. Very good questions. So his question is like this: kind of combine all things together. You set up 5 seconds to fail, maybe 5 minutes. Okay, as alarm call for 5 minutes. Okay, according to what I know. Okay, you know today I got sucks here. Kind of sucks. So my understanding is like this: you are setting the alarm clock to the chips or the hardware. When you suspend it, what happens to the chips? Also in suspension mode. Okay, and hardware itself is got suspended, and no signal will get fired there. But look at it in another way. When you suspend your computer, will the clock stop? No, the clock's still working, right? You won't find that, when I close the computer, after I open it, it is three days ago. No, it won't. The clock is still running. You set up the request for signal. After that second, it's still there. So when it's opened, it knows that it is the chance for it to fire. It will immediately fire the signal out. Don't wait for the so-called 5 minutes. This is according to my understanding. Okay? Yeah, but I've never tried it. You are welcome to try it. Okay? Any questions? No? All right. So